This question is asking us to expand two brackets. We've got negatives involved, so just be careful when we're multiplying out. I tend to like using the grid, y and -5. So we're timesing, so we've got y times y, which is y squared, y times -2, which is -2y, -5 times y, which is -5y, and then we've got -5 times -2, which is +10. So we've got a y squared. These two are talking about y's, so we can combine those together. So we've got -5y, take away 2 more y's, so that's -7y, and then we've got a +10 on the end. So again, we should check. Let's say y is worth 3, so we end up with this becoming 1 times, well, 3 take away 5 is -2, so that gives me an answer of -2. And then when we put 3 into here, we end up with 3 squared take away 7 times 3 plus 10, so we've got 9 take away 21 plus 10, and so we've got 19 take away 21, which is -2. So our check kind of worked. So it's important again, this idea of checking through at the end when we've got time to twiddle our thumbs and so forth, guys. So do check answers, because quite often here some people put negative something and then make a mistake, or they might put positive something here. Check it through, it's worth spending the time. This one has got a star next to it, so in other words we've got to show lots of explanations and working out, and some words to describe what goes on to prove what they want. So they want to prove algebraically, so in other words they're asking us to manipulate this in some way and show that it's always going to give us an even number when n is an integer value, so in other words when n is a whole number. So again we've got to be careful here because this says a bracket squared, so we're basically doing 2n plus 1 times 2n plus 1. And again we're timesing, so 2n times 2n is 4n squared, 2n times 1 is 2n, and that's 2n, and +1 times +1 is +1. So all of this gave us 4n squared plus 4n plus 1, and then it's saying we're going to take away 2n minus 1. Now here we've got to be careful, look, because we've got take away 2n, and then we've got negative times positive, so we've got to take away 1 as well. Alright, so it's really important we get that bit right. So we've got 4n squareds, no more n squareds, so that gives me 4n squareds. We've got 4n's take away 2n's, which leaves us with +2n, and then we've got 1 take away 1, which gives us nothing. So this is what we get from multiplying out the bracket and taking away the other bracket. And what we notice here is that both of these have a common multiple of 2n, factor of 2n, common factor of 2n. So we can refactorize this, so basically we can factorize this to 2n brackets 2n plus 1. Now what we should realise that this says prove that it's always going to be an even number. So 2n is always even, and even times anything that is an integer, which 2n plus 1 will be, is even 2. So therefore it's proved that we've ended up with 2n times this, and 2n is always an even number because it's a multiple of 2, so 2n is always even, and even times anything that is an integer, which this will produce an integer, because if n is say 1,000,000, this is 2,000,001. If n is 50, this is 101, and so forth. If it's a negative number, we're still going to multiply by 2n, which is an even number, so we'll just produce a negative even number. So that's what this question was wanting you to do. Prove algebraically, multiply the brackets out, end up with that, factorise it to this. The front bit is an even number, and even times anything is always even.